Okay, second video on the formula, addition formulae. I was just thinking about the intro to the last video, actually. I probably didn't explain that amazingly. And I think on the next question that we do, this one over here, that might start to explain maybe the origins of it a bit more. But the thing you just want to remember with the addition formulae is you're going to be asked to, as you did before, draw your right angle triangle, solve all the sides using Pythagoras, and then you're going to break out this formula to solve, and you're given the equation, broken out. So I'll come back to the kind of explanation of what we're kind of doing in reality on the next question. But yeah, let's just go through this one. So this is a little bit trickier this time because instead of asking us to find sine x and cos x, which the last questions have done, the question's asking us to find sine of 2x and cos of 2x. But that doesn't matter. And the first thing we do is we still solve. So we're going to find, I'll call this y since that's equal to x. The first thing we do is still just use Pythagoras. So root 11 squared plus 2 squared is going to give me the y squared. So 11 plus 4. Sorry, that's a takeaway. Sorry. Oopsie takeaway because I know the longest side. So 11 take away 4 is y squared. So y is going to be equal to, what's that? Root 7 then. 11 take away 4, 7 root 7. So this is root 7. So get that first and then label your triangle. So I know that this is the opposite, this is the adjacent, and this is the hypotenuse. The opposite's opposite the angle, the hypotenuse is opposite the right angle. So just label up so you don't make any mistakes. Now here, yeah, we can't do that, can we? I don't know how to do sine of 2x right away. I can do sine of x, cos of x quite easily. So what we want to do here is use our other trigonometric, I can never say these words, I do apologise, trigonometric formulae. So yeah, I can do this bit, can't I? So I've been asked to find sine of 2x. I can break sine of 2x into this. So I'm going to write that down and then solve that. So this is kind of getting us into one of the other video series, which is the identities, which is why I quite like this question of why I did it second. It's kind of drawing on the other equation. So that is 2 sine x cos x. So that's just 2 times, and the sine x is 2 over root 11, and the cos x is root 7 over root 11. So that's going to give me 4 root 7s, multiply the top lines, and that's effectively root 11 squared, so I'm going to get 11 on the bottom. Okay, the next one, cos of 2x. Well, you've got a bit more free range with this. You can pick any one you like, whatever one's easier. I'm actually probably going to, I would usually suggest doing this one, okay? I don't know, I just gravitate towards that one. I'm going to show you this one just to show you it in action, because I think sometimes people get the squaring of these wrong. Okay, but you can choose any one you like. So I'll write this over, I'll write it down here actually. I'll go over here. So cos of 2x is equal to, and that was cos squared x, take away sine squared x. So don't be confused when you see these, okay? You're given most of the formula you need. In fact, you're given all the formula you need. So the minute you see these, you should be thinking, look at my formula sheet, what can I use? So I'm going to break that out. And well, what does that mean? Well, it means cos of x times itself and sine of x times itself. So cos of x, we said that was root 7 over root 11. So that's going to be root 7 over root 11. And that's all squared, which means times in the top by root 7 and times in the bottom by root 11. So I could write that effectively as root times that. So it's going to give me 7 over 11. 7-Eleven, the name of the shops in America, isn't it? They also got the 7-Eleven. Love the 7-Eleven, man. Get a soda. I do amuse myself. And sine of x, we've got 2 over root 11. 2 over root 11, and that's all squared as well. So that's going to come out as 7-11, take away 4-11. So 7 take away 4 is 3. I've got 3 11ths. Okay, just to show you, that in action, because I think sometimes that's something people get confused by. They square the top, or they don't quite know what it means. Yeah, so it's root 7 squared, root 11 squared, or you're timesing it by itself. So that's the first bit done, nice. And the last bit looks a tiny bit different, doesn't it? Now it's saying by expressing sine of 3x is this, find the exact value of sine of 3x. Well, it's not much different, okay? We've still got effectively sine of a plus b. So I'm going to use my sine A plus B formula. So it's going to be sine and cos and sine. This is how I write it out. And the A is 2x, the B is x, A and B, and the signs stay the same. So you're given that up at the top, you're given on the front page. So you don't have to remember this, but that's just how I write it out when I'm doing it. That's how I remember it. So I've got this bit times this bit. Now again, this looks different from last time because at this point we could just substitute straight in. I can substitute straight in for this and this, but not these two. So again, this question's saying get your identities out and simplify this slightly. So let's turn sine of 2x into the only thing it can be, which is sine 2 sine x cos x, and that's now times by cos x, just doing the same. And for this one, I can turn this into anything. I think I'm going to choose, and you could do anything you like, 2 cos squared x, take away 1, and that's going to be times by double bracket around that, sine x. Yeah, I'm starting to spot. I think they're going to want. I can see a cos squared x popping up here, so I'm putting in a cos squared x over here. That's kind of the way my brain was thinking. I've got a sine x cos squared, okay? But you could put anything you like in. So now let's try and factorize and substitute this and get it a wee bit smaller. So 2 sine x cos squared x is what this bit gives me. And if I break out the second bracket, if I'm doing this times this, so I need to do the 2, I need to do that times that, and that times that. So I'm going to end up with 2. I'm going to write it the same way as the other one actually. It's going to give me 2 sine x. Oops. 2 sine x cos squared x, take away sine x. Okay, so all I've done is put the sine x in here. I could have written 2 cos squared x sine x. I'm just trying to make it a little bit nicer. So let's have a look. I've got this plus this. So I've got 2 of something plus another 2 of something. Notice these two are the same. So that is going to give me, actually, that equals that's going to give me 4 sine x cos squared x. Yeah, because they're the same. That's the same as saying 2x's plus 2x's. These are the same, so I've got 4 of them. Take away sine x. At this point, I think I'll make my life a bit easier, and I'm going to factorize. I'm going to take out sine x and say sine x. So that's the same as 4 cos squared x, take away 1. So that's me written this now in a way that I can start to solve it using my triangle, because I can only really put in sine x's and cos x's. I can't instantly put in sine 2x and cos x. You could have come out with a different arrangement from this, and it would still give you the right answer because you didn't have to substitute this one, and you could have substituted something else. But I just wanted to show you the ways that you can manipulate the formula here. That comes into our other equation. Okay? So now I'll start substituting sine x, so that's the same as 2 over root 11, that's opposite of what I put in use, multiplied by 4 times cos squared x. It's going to give me, let's see, cos x was root 7 over root 11. So I'm going to say root 7 over root 11 squared, take away 1. Okay, so it's looking a bit horrible, but let's tidy up. 2 over root 11, that's fine, times, and that's going to be 4 times 7, not 4 times 7 over 11, take away, now that's going to be an 11, so let's just put that in 11, eh? 1 is 11 elevenths, so that's the same as 2 root 11 multiplied by, that's going to give me 28 elevenths, take away 11 elevenths, so if I do 28 take away 11, 17, so that's going to give me 17 elevenths in there, times the top and the bottom for 34 11 root elevenths. Whew! That wasn't fun, was it? So I like this question. This is the trickier version. This is the kind of the A grade question for the addition formulae. But actually, when you look at it, all it's doing is incorporating other skills we've not done yet in a different video. I'm sure you've done them if you're looking at this video anyway. But it's looking at your manipulation of your formulae. Then you're kind of putting it together to make it something you can do. And then it's a bit of fraction work and a bit of surd work. So actually not impossible by any standards, just being comfortable with the formulae and being comfortable manipulating them. So get practice manipulating them if you're not sure. There's some good stuff in the Zeta textbook that you can use. We'll do a video on that as well. But yeah, more often than not, addition formula isn't as hard as that. It's more like the other video. Okay, so I hope that was helpful. Thanks very much.